Okay, so let's just jump right in. Imagine you're trying to build a state-of-the-art factory. Not in some tech hub like Silicon Valley, but literally in one of the most remote, undeveloped spots on Earth. We're talking about a place where even a decent road is a luxury. And that's where you want to build a high-tech, self-sufficient ecosystem. Sounds kind of crazy, right? Well, this is the story of Project Octagon.
And this image, wow, it just nails the whole idea, doesn't it? Look at this. On one side, you've got the raw, rugged wilderness of Karamoja in Uganda, and on the other, you see this digital nervous system, this web of technology that's meant to be laid right on top of it. That's the real tension here, right? It's about weaving this incredibly sophisticated machine into a landscape that's just wild and ancient.
So, that leads to the million-dollar question, or maybe the billion-dollar question. I mean, it's great to have this big, bold vision, but how do you actually get it done? How do you convince the best engineers, the big-shot investors, to pack up and move to a place that doesn't have any of the basic stuff they're used to? That's the core problem, and it's exactly what Project Octagon is built to solve.
Okay, so what is that fundamental problem? Well, the project's own documents have a name for it. They call it the Bush Gap. And yeah, it sounds simple, but it represents a whole world of incredibly complicated and, let's be honest, really expensive problems.
I mean, just think about it for a second. You need these highly skilled engineers, right? The kind of people who can run a plasma gasification power plant. But there's no reliable power. Or you need to fly in investors, but the roads are basically mud pits during the rainy season. This gap, this bush gap, it's why most of these huge, ambitious projects out in the middle of nowhere just die before they even get started. And this slide just lays it out so clearly. On the left, you've got the reality on the ground. Power that cuts out, internet that's spotty at best, and roads that barely exist. But on the right, you've got what the project needs to survive. 100% uptime, lightning-fast data, constant mobility. You can see the clash, right? You just can't fix that with the usual old solutions. So the big question is, how do you solve it? Well, Project Octagon has an answer. It's a dedicated facility they call Node 1. And the strategy behind it is this really cool concept called sovereign hospitality.
And this is where things get really smart. The whole idea isn't just to, cope with the lack of stuff. No, it's to create an overwhelming abundance of reliability. They're literally building a bubble of the first world right there in the wilderness. And that bubble? That's not a liability. It becomes their single biggest competitive advantage. So, this is it. This is Node 1. Now, it's important to get this straight. This isn't the factory. It's not the industrial part. The documents call it the welcome mat, or the concierge layer, which I love. Its whole purpose is to take care of the people, to make this massive, complex machine actually work for the humans who have to operate it.
Okay, so let's take a look at what actually makes up this bubble of reliability. First, you've got the lodge. This is where the key people stay, the ones the plan calls black start operators. Basically the folks who could get the whole thing running again from scratch. Then there's the depot. That's for the fleet of electric vehicles. You've got a super high-tech telemedicine clinic and a connectivity hub for that crucial high-speed internet. And the best part? It's all powered by the main industrial site right next door with a guarantee of 100% uptime. No blackouts here.
But here's where it gets really interesting, at least for me. It's not just about the buildings and the hardware. The real magic is the technology, the software that ties this whole thing together into one seamless system. And at the heart of that is something called RIOS. That stands for Rural Infrastructure Operating System. You can basically think of it as the project's digital brain. Its job is to automate and manage all that friction, all the annoying stuff about working in a remote place. We're talking everything from booking your flights, to calling you a ride, to getting you medical care. So RIOS basically has three main parts that make it work. First up, travel. Instead of calling a travel agent, an investor's AI assistant just talks to the Node 1 AI and bam, the whole trip is booked. Second, mobility. A fleet of autonomous electric vehicles they call Kurb Kars takes care of all the local transport. And third, healthcare. A clinic-in-a-box system gives them top-notch telemedicine, connecting the staff directly to doctors back in Canada. And here, you can really see that mobility solution in action. It's a fleet of 20 of these tough, autonomous electric vehicles, and they just run in a constant loop. They connect the airstrip, the lodge at Node 1, and the industrial park. Just like that, one of the biggest logistical nightmares of working out here is gone, completely solved.
Okay, but it's really important to understand that this hub in Uganda isn't just a one-off thing. It's not an island. We've got to zoom out now and see how it plugs into a much, much bigger global network.
So Node 1 is just a single piece of what they call the Octagon mesh, and you can see how it all works together. It's this symbiotic relationship. For example, Node 4, that's the big industrial part in Uganda, it gives reliable power to Node 1. And what does Node 1 give back? Housing and transport for Node 4's workers. It's a perfect give and take. And at the same time, you've got Node 2 up in Canada pushing out software updates, while Node 3 in Arizona is literally baking the hardware in the desert to stress test it before it ever goes to Africa.
And this is the really crucial part. Everything they learn in one place is shared across the entire network. So, for instance, the data they get on how batteries perform in the crazy heat of the Arizona desert, that data is used to train the AI that manages the power systems in Uganda. So what you learn in one climate helps you optimize the hardware in a totally different one. It's brilliant.
Okay, let's talk numbers really quick, because the financials here tell a fascinating story about how they made this whole thing self-sufficient. So to get the first phase of Node 1 off the ground, the initial cost, the capital expenditure, is projected to be about $184,500.
Now, listen to this. This is the really clever part. In its first year, the projected gross revenue is $133,500. And the key is where that money comes from. It's not from tourists. It's all from internal contracts. Node 1 is literally just billing the main industrial project for services like housing and transport.
And that smart little financial loop leads to this, a projected net operating income of $61,500. What does that mean? It means this hospitality node is cash flow positive from day one. It completely takes the risk out of the human side of the equation, all before a single paying tourist ever even steps foot on the property.
But look, the vision for this thing goes way beyond just cool tech and clever finances. At the end of the day, its long-term success is all about the people.
And that's why the entire on-the-ground show is run by a company led by this man, Mike Tumasige, who's an expert in Ugandan tourism. And this is so critical. When you put a local leader in charge, the project gets what the documents call a social license to operate, and make sure everyone sees it as a genuine partner, not just some foreign company coming.
And that local integration goes even deeper. The whole strategy is to build what they call a sovereign cultural loop. The idea is to create real economic interdependence. So what does that look like? Well, it means setting up farm-to-table supply chains, buying honey from local beekeepers and meat from local pastoralists. And that high-tech telemedicine clinic, that gets opened up to the community too, so it becomes a shared resource for everyone.
And you know, when you step back, the project is really asking a powerful question. It's challenging that old-school model of development. Instead of just showing up, extracting resources, and leaving, it's proposing a new way. Building a self-sufficient, high-tech ecosystem where everybody wins, both the big industrial project and the local community it's a part of.
Because look, all the heavy-duty stuff, the power generation, the AI number crunching, that all happens somewhere else in the network. But Node 1, that's the face of the project. It's the real, tangible, human-sized proof that this entire incredibly audacious idea can actually work. In the end, it really is the welcome mat for the machine.